Things appear to be live. So just make sure everything's working close enough. I must have my speakers way down for some reason. Why would I do that? I don't think I need them, but it almost makes me. Oh, okay. The volume's way down. Should be okay. Just make sure. Close enough. All right. Just my problem, not your problem. And that's not what I want. Wrong background and such. And this is the wrong video and such. Where's Firefox? Looks like that's it. Okay, that's the one. All right, close enough. So this is sort of an overview video in the sense that it's not a particular subject beyond the subject being the one particular function of the universe, which seems to be the only function of the universe, which is sort of this idea of motion or stuff moving, what we notice. And we notice it because it takes time for things to do this moving thing. And and it's just all about why something moves, how it acquires this function of moving. And the simple answer is there's only things moving. The universe is made out of a bunch of little stuff that's moving. And the little stuff is held by the bigger stuff, caught like fish. And the net function of what it holds as movement defines where it goes. So what it captures is what it has. And if it captures opposing forces, then it will neutralize to no force. But they're still real forces in a sense. They're real things doing real stuff, but they neutralize each other in terms of there'll be no net effect. So things that aren't moving have stuff inside of them that can be moving, and that's potential energy stored in them, in the sense that it's energy, in the sense that it's these free bits. So the free stuff is what we call energy in a sense, because it looks energetic, it's moving. Movement is in a sense a kind of freedom, and the faster you're moving, in a sense, the more freedom. No, I don't even know if we need to get into this free word. It just makes a mess. So, Thailand. Ugh. Dank mosquito. Interesting name. Thailand, though, must be an interesting place, but every place is interesting, right? I mean, there's some kind of stuff happening, stuff moving everywhere. So I'm sure Thailand has lots of stuff moving to be interested in. All right, so I've sort of pointed out that my theory is basically this kind of school of fish theory, the idea that you can trap motion and there can appear to be no motion. And what really is happening is whatever you've trapped in terms of little stuff will decide what your big stuff does. So if I put a space shuttle engine on one side, I'm essentially making exchanges. I'm basically throwing a bunch of fish into you, moving one way, letting go a bunch of fish going the other way that you see as the big flame, and converting you into something that has more stuff going this way than it has stuff going that way, and therefore you go that way. And it's just creating a bias in terms of a lack of symmetry in terms of what you own as movement. You have more movement in one direction. You maintain that bias until something forces you to renegotiate and create a different bias. And then your bias might be just static again. No movement. All right. Yeah, it's just an overview. I'm just trying to get to the point that this is all that this relativity stuff and quantum mechanics are really just efforts to describe these moving phenomenon. So relativity has taken the place of like a rational force equation. but what it's really talking about is gravity. And so gravity has become some sort of bent space-time thing, where magnetism, most people don't think of that as bent space-time that makes magnets move together. They think that it's got to be some kind of force thing, some sort of, I'm going to argue it's just this little fish stuff. It's just the same force that you see all around you and that the light bulb produces. Light is a force moving the speed of light. So I've sort of emphasized this point over and over again, that if people kind of thought of it that way, speed of force, that maybe they could understand that light is just one manifestation of force. So I just don't like the way I'm starting this video. It just doesn't seem like I'm getting where I want to go. All right, so I've sort of pointed out. So light is just this idea that, let's see, can I make bigger blobs? I don't know if I want to make bigger ones, but I just want some easy way to make a blob. All right, so the idea would be is these little fish, all right, they all have a direction to them. Oh, I can make arrows with the line tool. No, I don't know if I want to get into all this crap. Pencil. Does the pencil have arrows? No. Something had arrows. I guess it's this line has arrows. Yeah. Arrow. There we go. All right. So all of this stuff has a direction to it. So you could just do it as a bunch of little arrows, and they're all moving in the same direction. And so you'd say, okay, that's light. Little bits with a frequency. So if I make the frequency longer, then I can do it with a color just to illustrate the point. Shouldn't really be necessary. So if I made these arrows further apart, you can see, okay, that's the difference between red and green light, is the red light is further apart than the green light. So obviously in a certain amount of time, there'll be more green potential power, in the sense there's more fish, okay, than there are red fish. And the idea would be is that this force stuff hits things, and it can either just, it can either, so it goes into something. It can either just reflect back. Oh, it's putting that box around, but anyway. Or if it goes in, then it can get trapped in what I've described as, any kind of trap. It can be a back and forth trap, but the more obvious trap is this kind, where it's going around in a circle. But the key to the circle is, so if I throw energy in, okay, with this arrow, and this is a separate thing. This thing is an independent little box. I don't want an arrow now. Yeah, I don't want an arrow. So let me go back to the drawing tool. So this is a separate little box here, and it has frictionless wheels on it, or however you want to look at it. So there's no friction. And so you push a fish into it. You put a bit of force into it going in this direction. And let's say it does this thing frictionless, where it makes these turns. So it goes in a circle, or it goes in 4 right turns, however you want to look at it. The idea is that this motion, the initial motion, this way, is retained. So the box doesn't go up, the box doesn't go backwards, the box doesn't go down. This box on wheels, while it holds this arrow, will go this way. And it'll keep going that way. So it was standing still, minding its own business. It captures this thing. The thing goes around in a circle inside of it, and it retains, though, this little extra first step. This little first move stays inside of it. So this is like the conservation of its momentum, conservation of its vector, its direction of momentum, its angular momentum, essentially, is conserved. This was the direction of the momentum in 3 dimensions, its angular momentum. And this thing that is frictionless will retain that motion as long as it retains this trap. So as long as this stuff stays trapped, this motion stays in it. Now, if it lets the motion go in, say, some other direction, so it lets the arrow go in this direction, like an orbiting body or something. The trick is that's only that's releasing energy, but it's not releasing all of the energy it consumed in this direction. So what it's going to sacrifice is some energy this way. They'll create an imbalance going this way, and there'll still be motion this way. So the net effect will be, now the motion will be in this direction. It's that kind of thing. So you're always retaining the value until you give away the exact opposite. So until you give away something that is in these, this, it's always 180 degrees to these dimensions, so you go by the 180 degrees of the dimension. So until you give back the exact opposite of what you put in, you're going to keep moving. You're going to have the imbalance. You'll just change the direction of the motion, depending on how much of you give back in some other direction. So when a satellite goes around a planet, for example, it's stealing some energy by doing that orbiting, changing thing. And as it leaves in a different vector, so if it goes in this way and it leaves going this way, this way, it will have made an exchange of forces. And all the fish, when you add up all the fish from both the interacting things, you'll find that all the fish motions are conserved, so to speak. So it only works as an analogy with fish if you think of the fish as being things that can't on their own change their direction, that they have to be forced into a trap, and that the trap is frictionless. And that's the key to understanding all this stuff. But it's that simple. Like everything we see is just these conversions. There's nothing complicated. It's just all these little force bits give you an acceleration. So like when Einstein says all acceleration is the same, it's true in the sense that all of it's created by capturing some hunk of crap moving in a direction. That's what acceleration is. Matter is the only thing that can be accelerated, because matter is not moving the speed of light. All the forces are moving the speed of light. So all these little bits are all doing exactly the same thing. And the ones we call electromagnetic spectrum things, light in that category, radio waves, the cosmic rays with light in the middle, all of that electromagnetic crap is just this stuff at a frequency. And then when you take away the frequency, you just have stuff, you just have arrows. As I've argued, that's just, see if it stays with an arrow. Yeah, it does. That's just, gravity is essentially just a bunch of that stuff, but not with specific frequency. It doesn't have a reliable pattern. And it comes in two varieties. It has a polarization. I just hate to have to keep changing this stupid thing. So it's mixed. Now, the electromagnetic spectrum, the light stuff, is all one color. It's all just one type of the force, because it only affects the electrons. It's not a proton significant force. But that's a subtle difference that isn't terribly important. But this is all that gravity is this mixture without any frequency. And then magnetism. So you have light that's just the stuff at a frequency. Period means everything. How much distance between the little fish? The fish are still moving the speed of light. They just have distance between them. So they're coming at a periodic rate. And we know that things happen at a periodic rate for lots of reasons. The clock goes to 12 o'clock in every hour. It's a period. So lots of motions can have a period to them. Any orbiting thing, anything doing this circular trap thing has a period. 1/4 of the time it's essentially going this up and down. 1/4 it's going left to right. 1/4 it's going up to down. 1/4 it's going right to left. I mean, it's a period, a reliable period. That doesn't sound good, but anyway. All right, so that's what light is. And so this model, this simple model of light, explains all the stuff that's out there. It explains the infrared, the ultraviolet catastrophe, and it explains the photoelectric effect, and it's perfectly powerful as a device for explaining why different light has different effects. All right. Then there's the third option here, which is the magnetic force. And as I've sort of demonstrated, is all the magnet does is, I guess we just draw it in some sort of sloppy manner. It's typical of my functionality here. And then we'll have to change it. See, I wish I could just hit this. Maybe this eyedropper thing will work, but I doubt it. No, it doesn't work. Useless tool. I don't know what it does. I don't know how to use it. I don't know. This is interesting. This program is really quite a pretty good little draw program, HTML, all that stuff. But there's absolutely no information anywhere on how to use it at all, which is, I mean, it's totally obscure in terms of nobody uses it. A very nice HTML paint program, and nobody on earth uses it, which is kind of funny, I think. So, so the force goes in, gravity. It affects the thing just like gravity would do. But after the gravity affects this thing and accelerates it based on gravity, so that means the arrows above are going to push it down. It does the gravity thing. It converts the gravity after it's done with it, after it's been affected by the gravity, when it leaves the object, okay, is going to leave with, whoops. Well, I guess I could do the red coming out of the green. What harm would there be? You won't mind. So all the reds come out of the green, and all the green will come out of the red. Well, that really is just going to confuse you, but hell with it. So that will be the filter. The filter is it comes in mixed, and it's going to leave segregated, filtered, transformed. So the energy will be the same. It's just what's carrying the energy, that is green fish, red fish, will change. But the net energy is still the same. And so the magnetism doesn't come out as a frequency. It comes out mixed, no arrangement beyond the fact that you have all of one kind of the force coming out of one end, all one kind out of the other end. And this perfectly explains why, because of the inverse reactions these two things have to each other, in terms of the reds reflect off red and the greens reflect off greens, and therefore creates more pressure or less pressure. I've explained all that stuff in other videos. And it explains exactly how nucleuses of atoms are held together. It explains why electrons and protons behave the way they do, because the electrons and the protons are essentially the material component representing these two colors. So there's electron force, which reflects off electrons. There's proton force, which reflects off of protons. And then the proton force goes through an electron and comes out perpendicular. So the force changes its vector when it goes into an electron, and likewise with a proton, which means the force can't stay between the two objects. So if you put an electron with a proton in the middle, the two electrons, even though they're repelled by each other, will move much closer to each other, because all the force that would cause pressure between them will leak out of the proton. And vice versa. If you put electrons between protons, you'll be able to get the protons very close to each other. All right. So, yes, so this simple one force. So no quantum mechanics, no relativity, no bent space-time, no virtual photons for the magnetism, no interference wavicles for the photons, no complex behavior at all. Just stuff that has a periodic function, in the sense that it's really raining, if we need any more of that. It's just periodic. It just it's another word for that. Yeah, I'm not thinking of it. But anyway, and yes, something that comes at a frequency can appear to be wave-ish, because waves do that. Waves have a frequency. But you don't need to have a wave to have a frequency, just like I pointed out with bullets. Bullets, you don't really say a wave of bullets. I mean, some people do when there's a ton of them. But, I mean, you understand that they're not really waves of bullets. They're bullets that are so dense that they have the appearance of waves. And waves just have the appearance that they're doing something other than just moving molecules of water. And in the sense, they're just pushing bullets, pushing bullets. So instead of the bullet independently just flying from one location to another, it's like dominoes. The one bullet pushes the other bullet, and the next bullet pushes the next bullet, and the next bullet pushes the next bullet. So they're just pushing each other rather than actually traveling the distance. So there's no wave isn't a relevant concept. Period is. How often something happens and how regularly it happens is important. But wave isn't. Because there's no medium here. There's just little bits of stuff moving the speed of light. And it can be formatted, can be arranged in different configurations that give it different effects. So when you configure it certain ways, it will have certain effects. Just as in this experiment from the beginning here, I was talking about this little circular thing, and maybe you understood that trapping this circle means you trapped the initial momentum. So the circle doesn't change the initial momentum. That's still inside this box. The circle just means it stays inside the box. So it's captured. This movement, the movement in a direction, is kept by just forcing that movement to do this circular thing. Because then it can just keep doing this over and over and over with a period. It can keep pushing this way over and over and over again forever, essentially. And that's what gives things their momentum, physical, material things. That's why they keep moving in space, is because they've trapped energy in these little circles, these traps, and they just keep doing it over and over again. Now, I could make this trap just back and forth. I could, theoretically, and it would work, just have the force go in, bounce off a wall, bounce back and bounce off a wall, and then bounce back and bounce off a wall. And even though it looks like it's just back and forth, it's really forward. And again, it'll be an effective trap. And the trap will have a real momentum in this direction. The overall effect will be, it will move the box forward, and it will keep moving forward until I get rid of those two reflecting walls. Until I get rid of those paddles. So it's essentially a ball is flying through space. I'm an independent device, let's say. And I stick a paddle up, and the ball hits it. And then it reflects. And I stick another paddle up, and it reflects off this. All frictionless. Reflects. And then it hits this one again. And then hits this one again. Hits this one again. The idea is I've trapped, like say it was a cannonball. I've trapped the cannonball now. And it'll keep pushing me. So I'll move, not with the same speed of that cannonball, but that speed as a push, a constant periodic push. It will, based on the period of the trap, it'll keep hitting me and keep pushing me. So depending on how big the circle is, the trap, I'll keep getting poked with a direction. I think that's safe. There's certain things when you say them certain ways, you have to be careful of the precision of your language, because you can make a statement that's not entirely what you wish to imply. And there's also obviously a ton of that in physics. So I want to chat, see if anybody said anything worth noticing. Oh, notice of eviction. Yeah, you left some idiotic crap on my, I mean, it's just, what is this invade my personal life crap, doing this crap? What is wrong with you? You sicko. I mean, it's obviously the cowboy. let's see what he said. I thought the distribution of twans was random. I've said 4 million times there's nothing random in the universe, but obviously it has the appearance of being so even and symmetrical that you can't tell the difference between it and random. Yes, so for all intents and purposes, it's entirely random. Gravity is a random thing. Photons are filtered. Photons aren't created by the universe. Light, little bits coming at a period, isn't what the universe creates. That's what's created by matter when it lets the force go. It sometimes lets it go periodically, and then we can see it as light. You dumb fuck. Anyway, why would the configuration continue moving forever until it meets matter? Well, matter's just the conduit. So all there is force in the universe. And you throw some little matter bits in the middle of it. They never had any motion. You just drop them in this chaos field. And the fact is, okay, it's a fact. Mock gravity, look it up. This is a fact. So if I took a bunch of BBs, little copper BBs, and I energized them into a chaos, a random field of little bits banging into each other, and I put, say, plastic checkers into that field, the little BBs will knock them all together. It's a fact, okay? So in a sense, the matter bits will act as a conduit for the force bits to interact with each other. The force can't interact or do anything without the matter bits to interpret them, to translate them. Dummy. Okay. Why not random walk, whatever that is? Because it's just not the way it works. It's not the physical property. The pressure you're unequalizing the pressure when you have two things in a field. You've unequalized the pressure. When there's one thing, the pressure is equal. Same amount of pressure from all locations. When you put two things in, you create shadows of pressure, essentially, because it's all straight line force. You see, in straight lines can't go around and hit the other object. So both of them end up shadowing each other, creating less pressure between them, and they will inevitably be pushed into each other. I mean, it's so simple. And it's just amazing to me that you people can't understand how simple that is. It's such a simple fact. You can just think about it. I mean, it's just, yeah, obviously, if there was just straight line force and it had to come from outside the circle these two things are in, right? These things create a frame. You like the word frame. Well, these two things create a frame around them, all right? And the force outside that frame, you can see that there's locations where that force can't hit the other thing because it's in the way. And that's a shadow, essentially. And that shadow represents a lack of pressure hitting something. And so if there's less pressure on one side, more pressure on the other side, that it would move this way. And that this wouldn't be doing exactly the opposite. It would be moving. It's so obvious. You can't understand that? Remember, the light is traveling through a field of bits. So again, no, it isn't. As stated a million times, these little bits can't interact with each other in any way you can see or notice. If they hit and reflect, or they miss each other, the universe looks exactly the same. There's one bit coming this way, there's one bit coming this way. If they reflect, there's still one bit going that way and one bit going that way. And if they miss, there's still one bit going this way and one bit going that way. See, absolutely no difference. Idiot. God damn. You are so fucking dense. It's insane, the amount of density. Insanely, like, black hole density. All right, bouncing back and forward between two walls does not make an imbalance. So again, it doesn't have to. The point is the momentum is real. The momentum vector is a real thing. And no matter how funny you do a path, that you add to that momentum vector. It's just like a charge circumstance. If you have a charge path, if you move a path to get to a charge and you do it up and down like this or something, it doesn't change anything, because every time you move off the straight line, it'll automatically be plus and minuses, because the only thing that's going to matter is the straight line in the end. So all of this extra motion will never be work, because all of it will be considered nullified when it's frictionless. It doesn't mean anything. It can't mean anything. And you can't undo the fact that the force bit has a vector of momentum. And so that if I make it do this cul-de-sac thing, the fact is when it gets back to this 0 point, it still has this motion. So it's going to go that one step further. So this motion at the bottom nullifies this motion at the top, but it doesn't undo the first step that created this motion. So you have to understand that this motion is the size of this battery plus one step. And the motion up here going the opposite direction is just the size of the battery. So there's always the one step remainder. Then you never get rid of that. Okay, I don't get how that would imply movement in a direction. I'm just saying that understand the logic of just the closed system. Without friction, how could you possibly knock this into this, like kinetic balls? Doesn't this kinetic ball have to move? I mean, doesn't it have to? It doesn't have a choice. Okay, it has to absorb this motion. And until it hits another ball in front of it, it's going to keep moving. It can't lose the momentum. And the truth is what the momentum represents is a little bit of force bit, little fish. Little fish have to get caught and trapped by this piece. This piece traps them. And as long as it has them trapped, it moves. And then when it hits something else, it gives the fish to the other guy. And now it doesn't have them. So it loses those momentum points. And now this one has them. It's just transferring a real force. It's a real motion. And like I said, again, trapping it in a cul-de-sac doesn't stop it from moving. If I take a car and it's driving and I move it into a cul-de-sac, you could sort of understand that's not going to stop the car from moving. Now, what you won't understand is that somehow the whole cul-de-sac is moving, but it is. It's applying a pressure. If you did it, if I could make an island floating, and then you drove your car into the cul-de-sac in one direction, the whole island would move. All right. And we just keep moving with that initial. How you initially got into the circle is the motion that's going to decide how the island moves. Now, the island could spin, and that's getting into a whole nother argument. But the idea is you're capturing the momentum. So the spinning is actually still capturing the momentum because you're spinning. But I don't want to get into that. I don't want to get a conversation about the difference between spin and forward motion, because one of them is kinetic and one of them is potential. So one of them, you're converting the energy into potential energy, and one, it's in the form of kinetic. Do I have anything else to say about that? No, it really doesn't matter, because even when you're spinning, you're still have the vector of the motion. It's just going to be slower. So your spin could be very fast, but your motion as you're spinning, you're still going to have it, and it's going to be one fish worth, one car against the mass of the entire island. So it's obviously not going to be a great deal of velocity, but it will be a velocity. All right, let's see. I understand you say the sum of vectors becomes one vector, one momentum vector. Yes, clearly, if you have trapped, you could trap something in a circle this way. You could trap something in a circle this way. You can trap something in a circle this way. The point is where the meteor came from. Like, it's meteors hitting the Earth. Where they came from is going to be the more important thing in terms of what the momentum impact is. And that's really all that matters, is the real thing you're absorbing is the direction, the initial hit. And that has to be conserved. That original vector of energy is what you're conserving when you move the earth in some way. The only way you can conserve it is you have to, if you lose force or pieces, fly off in different directions, or whatever. Specifically, bounce back and forward between two walls makes the momentum vector 0. So again, no, you're not understanding. Okay, that's like, again, so you're thinking I've now killed this forward motion. So you're saying when I put something into this loop, all right, so I make something go into a loop, you're saying now I've undone its momentum and now it's 0 again. So it came in and now it's completely 0. When no, you still haven't gotten rid of the initial momentum where it made this first turn. So where it made this first turn, that was like a first step. So that's a little tiny extra little arrow that's still there. So this is nullified. That equals 0. But this, you never got, you didn't get rid of this. Okay, I wanted to make a circle, but I can't do it with this arrow. Do it with the other drawing tool until I have to switch tools and all that crap. This little bit here, you didn't get rid of this. So this bit still exists inside that initial step in. The initial step in, you haven't undone. Okay. I just don't know how to say that any other way. The backward motion will never undo that first motion. And you can't destroy the energy. So you see, by your theory, if that worked, all I had to do was put it in a cul-de-sac, and by the time the car gets to the end of the cul-de-sac, it somehow runs out of gas or runs out of momentum. So if I have a greased track, so there's no friction, and you push the car into the cul-de-sac, you're kind of arguing that somehow the car runs out of momentum and stops. No, the car will keep going around and around and around in the cul-de-sac. And each time it goes around, it's pushing, essentially into a new loop. And the push into the new loop is still its momentum. I'm just saying, if you made the device, you'd see it works. You could throw something with moment, a tennis ball, into a device and say you could make a frictionless loop where the tennis ball gets stuck in. You'd be able to see that it actually works. The tennis ball goes in, tennis ball gets stuck in the loop, and the device keeps rolling because it's absorbed the motion vector of the tennis ball. All of that energy is still applying itself to all of the matter of the device. So the device picks up the motion of the tennis ball because it owns the tennis ball. It now owns that piece of force. The force can't be destroyed. You can't destroy the piece of energy. And the energy is now in the thing with the wheels on it. And it's going to roll until you let the tennis ball go. You hold it, you own it. That's simple. So I mean, it'd be nice if I can analogize this with fish, but I'm just saying, obviously the fish are in a group. If I put a new fish in, you can't kill the fish. The fish still is a little energy machine, and its momentum going in is going to be affecting the rest of the fish. Now, as long as you don't make it, like I said, fish have the ability to use their own stored energy to turn and do all kinds of stuff, and that's using their energy, which is releasing new force vectors. So I don't want to get into all of that. The elemental forces can't change their direction using their energy. They have to be changed by the matter inside the matter. But again, it's frictionless. When an electron, when a piece of force hits an electron, nothing's consumed. No energy is consumed. It's just released in a new direction. The reflection doesn't consume energy. An absorption doesn't consume energy. Nothing consumes anything. You can't kill the fish. You can't kill a photon, for example. A photon goes into something, it rolls around inside of it, and then it shoots out again. But while it was in the thing, it's still moving the direction of the photon, so to speak. Its force vector is still real, even though it's exchanging it for this, and then this, and then this, and then this. The bottom line is this was the first one, and this is the one that it has to release before it will stop moving. The first one is the one that creates the imbalance. And until you let it go, the whole school is going to be affected by it. You know, I've got to find some more analogies. It's just so simple, but it, you know, it's just I got to find better analogies. Because this is, you know, it's important. I mean, if you understood what I was saying, then you'd understand. Oh, I get it. This does explain why. This explains everything. It's just forces with little matter bits being pushed around by the forces in terms of the matter bits are changing the direction of the little force bits. And so it's allowing us to see interactions we wouldn't see. We're seeing things because the blue force and this color force are hitting each other and then reflecting. And now the universe is different. Yellow battery was going this way and blue battery was going this way. And now it's the opposite. Something changes, this kind of thing. And that change is the change that all complexity is made out of. You know, I've been over that. Okay, let's see. All right. When a sum of vectors arrives at the starting position, we're already in trouble. When a sum of vectors arrives at a starting position, yeah. So when 6 things are banging into one thing, that doesn't. You're not going to get this elemental part by doing that. You end up with a 0 vector. No, you only end up with a 0 when you have 2 opposing forces. That's it. They have to be exactly opposite. You absorb this, and then you absorb this. So you absorb this in a loop, and then you absorb this in a loop. Well, now you have a net 0. But if you absorb this into a cul-de-sac, you don't have a net 0. You have a net in that direction. Just a fact. Okay. So maybe it's not a circle, but a spiral. Well, obviously it's a spiral in the sense that you could argue that it processes. So if it goes in, it processes in the trap. But what I'm saying is it's a frictionless trap. So the trap really doesn't care. It doesn't have to process. Matter's got, you know, an apple is to the earth what an atom is to an apple. I mean, there's, you know, the density of these exchanges are happening on such a minute and tiny level. You just kind of have to understand that all they're really doing is this kind of thing. They're just exchanging directions between forces. So when there is a turn, the turn is being created by this kind of interaction. There's no friction in it, but it obviously does change vectors. How else to say that? But you can't, like I said, this motion isn't undone by this motion up here. This motion is the first motion, and it has to get undone by another motion this way, technically. So in a sense, this was the first move, was up. See, when this hits this is the first move. Then this is the second, then this is the third, then this is the fourth. Those are the ones that got neutralized, not this one. Yes, well, pool table is a decent enough example, except you have to kind of get rid of the walls and, you know, not think about walls so much as think about a million pool balls. And the idea is you have such density of interactions that the interactions never even reach the cushions. There's so many pool balls and these little balls in between the pool balls. So it's pool balls getting hit by, you know, BBs. Something like that. Hi, hun. I like the hair. Well, you're not going to last long here. They would have to cancel each other out exactly. That doesn't mean anything. Like a pool table. Like there's no canceling out on a pool table, and a pool table has friction. So if you take the friction off a pool table and you hit a cue ball, it's going to bounce around the ball table forever. No matter how many balls you put on the table, the energy will never leave the table, ever. You'll never make it stop unless you throw a ball in from exactly the opposite vector. If you throw a ball onto the table from exactly the opposite vector from the initial ball you threw in, then you can stop the system. But until you do that, you can't. But yes, you're really close to just getting blocked. Fucker. I mean, you people who can't deal with people's hairstyles are just amazing. You're distracted by that. I'm a human who has naturally, this is natural hair, by the way. Okay, I didn't dye it pink or something. I didn't make a statement with it in some way. I didn't form it into something to say, notice my hair, notice my hair. I just let it grow on my fucking head like I let my eyebrows grow. And you have to notice it? Fuck you. Do you braid your pubic hair? I mean, who are you, fuckhead? It's just a gratuitous way to create distraction that doesn't need to exist. Just absolutely irrelevant bullshit. The tactic of an asshole who can't form intelligent sentences. It was actually a compliment. I don't know. Why should I take it as a compliment? Hi, hun. Why should I even take hi, hun as a compliment? What does hi, hun mean? I mean, I hate to tell you, but I'm not your hun. Just not. Yeah. I mean, I really don't, say there's a girl doing physics on the internet. I mean, I really wouldn't, even though I might think it. I really wouldn't type, hey, chickie poo. I really wouldn't do that. Well, that's cliche stuff, right? I mean, women peeing themselves. So again, you're just being kind of cliche. I mean, you wear culottes too. I mean, how far does the cliches go? Sensible shoes? I don't know. All right. Well, anyway, I'm not a very personable person, so I'd like you to keep the comments relevant to physics and not do all this personal stuff. That's what I'm intending to convey is keep it physics. So I really don't want to do personal shit. All right, so back to my conversation. All right, so I think I gotten to the point that the idea, so conventional physics has done what I think is just a really horrible mistake, which is to take the force of gravity and completely separate it from magnetism in terms of mechanism and pretend that there's some kind of bent space-timey thing that's doing gravity. And this magnetism thing isn't bent space-time, it's some sort of other field, virtual field wave thing. And they think it's a wave thing because they tied it to the speed of light. See, they found out magnetism moves the same speed as light. And because they were convinced light was a wave, they said now magnetism's a wave. There was no reason to do any of that. There's no wave in magnetism at all. It doesn't appear to do any of these interference things. It doesn't do any waving things. It doesn't come at a period. I mean, magnetism doesn't turn on and off. It doesn't go, I'm magnetism, I'm not magnetism. I'm magnetism, I'm not magnetism. Unless you have an electromagnet and you have a switch and you turn it on and off and on and off and on and off. So unless you make it wave, that is, have a frequency, it doesn't have any native frequencies at all. No sign of any frequencies at all. All it has is a strength, and that strength will force the magnets to line up at a certain distance based on their attraction and their repulsion. So a row of magnets could end up looking periodic, just because of the force between them, the amount of force. But there's no wave here. There's no intent to create some kind of period or something that would appear wave-like. But anyway, so this is just a catastrophic, destruction of the foundations of physics. And I just don't see why most people can't agree that that does appear to be a problem. Like if you were to diagnose, if you were to accept for a minute that it is possible to have the wrong answer, that might be a very good place to look for how it all went wrong, was separating gravity, a force that moves the same speed as magnetism and the same speed as light, to separate these functions from each other and pretend they're created by different mechanisms when they have every appearance of being completely connected mechanisms, in the sense that they do, all of them do this inverse square law thing. All of them do this radial force, straight line force. Magnets is a straight line force. Magnetism doesn't go around curves and doesn't do a lot of things. They have so much in common, and they have no appearance of being waves in a medium. They don't do anything that looks like waves in a medium in their normal function. And the only time they make light look that way is when they do these stupid slit experiments. But otherwise, there's no evidence that they're anything like, pushing dominoes. Again, I don't know what, it definitely pushed your buttons, didn't it? My button is I find human beings who can't stay on a subject, can't take anything seriously. I find you obnoxious, repulsive, disgusting. Yes, that pushes my buttons. You're glib, distracted idiots. The world is in a mess exactly because of people like you. Superficial, synthetic, cheap dumbasses who can't understand anything, can't stay on a subject, can't take anything seriously. They're just glib fucks who walk around going, "Hi, hun." Yeah, that's why the world sucks. Too many people with "hi, hun" on their mind. So we're done with it, Francis. You could have just apologized and said, "Sorry, I didn't realize this was a channel for intelligent people to have intelligent conversation. I just thought I'd show up and take a pee in the room." Fuck you. God damn. I don't know how I have the patience to go on. just don't know how do I endure this day in and day out, being on this imbecile planet. Fucking mongoloids, a bunch of fucking mongoloid retards. I am trying to educate you. I don't have a choice. There's just absolutely no choice. I mean, if I was on an island full of chimpanzees, I'd sit there and I'd definitely try to teach them English. I mean, every day I'd be talking to them, trying to get them to get some basic, hey, don't be shitting in the living room, God damn it. All right, so I have a whole little thing written here that I probably should have scanned into the computer and then I could just reference it, but I don't know. It's all connect the dot kind of crap, so there probably doesn't no point in it. All right, so the real key thing is to understand that all the energy is in the movement of the little bits. So all the little stuff going the speed of light. Now, gravity is going the speed of light. Let's just pretend, for the sake of arguments, just accept my argument that the gravity is these little bits moving the speed of light, and that the magnetism is these little bits moving the speed of light, and that light is these little bits moving the speed of light. That's where all the movement is. And so back to the analogy that the matter bits are dead bits you put in that field of this stuff moving. And when you first put it in the field, right, initially, there's just gravity, right? There's no other, you haven't created any stuff moving at a period yet. So there's no light yet, you know, and there's no magnetism because you haven't created any mechanism for segregating it. Because the little matter bits you're putting in are all random too. So until you start making things that have all the, you know, all the electrons on the outside and all the protons on the inside, well, now you're creating something that can create this segregated effect. It can create this polarization where more red stuff is coming out of one end and more green stuff is coming out of the other end. And once you create that imbalance, then all you have to do is rotate something with that imbalance. And then all of a sudden you'll have red stuff, green stuff, red stuff, green stuff, red stuff, green stuff. Now you have stuff periodically being shot. So, I mean, there's just so many ways to describe how you can create these, the mechanisms that create what we observe. Yeah. All right, how else to get to this? It's an interesting thought. If you spun a magnet, you'll very quickly. I wonder if you could spin it fast enough to create nanometer light, but that would be gigahertz speed. So yeah, I have to figure out how fast. It have to be a very small magnet, of course. Yeah. But anyway, it would be interesting whether you could actually do that. You could actually take a magnet, spin it fast enough, and then create that period, that on-off pattern, where you're shooting more black force or green, however you want to look at it, you know, at the right period to turn it into a visible signal that our eyes could receive. Quite possible. And such. All right, so yeah, that's the thing I'm emphasizing here is there's free force, those little bits, and then they end up being captured by the matter bits. The matter bits are atoms, let's say. Well, the little matter bits are just the electrons and the protons. Clearly, the electrons and protons get in patterns, and then once the electrons and protons are in patterns, they can force the bits into the cul-de-sacs and trap the force. So it requires a certain amount of complexity before you can trap force. And the minimum amount would be something like a hydrogen nucleus, no, a helium nucleus. In terms of the smallest thing you could throw into space and it would keep going because it trapped the force you threw into it. Where the electron can't trap the force, it can only hold it. It can only be accelerated. And when you stop accelerating it, that is, you stop pushing it, it stops moving because the force is always getting rebalanced. The field energy is constantly hitting it and undoing the imbalances. I don't know how to put that in some other way, but it can't trap the energy. It has no mechanism. It has no cul-de-sacs. It has no mechanism to cause it to create a trap. So it can't eat fish, can't hold new fish, the electron has no school mechanism to allow a fish in and keep the fish in the school. Probably the way to analogize it. All right, so but that gives you one level of complexity that makes the argument more complicated because matter has a transition. So you have the force bits, and maybe we can all agree on what they are. Just the tiniest things in the universe moving the speed of light, and you can have them color segregated, all black, all red. You can move them at a period, you know, a specific frequency. So you have three ways to manifest that force stuff. And then the matter is composed of the electrons and protons, which are the monopoles of the magnetism. They're doing the inverted reaction to the force, but they themselves are weak in terms of they can only be moved by the force. So they can only be accelerated by a specific force, has to be hitting them in a specific amount of time from a specific direction. They only just go wherever the imbalance is. So if an imbalance hits them this way, they move one step that way and they excrete that force. They don't get to keep it. So they release it. They don't create a permanent shadow. Yeah, that's a good way to put it. They can't create a permanent shadow. They can't consume it and just keep moving. They can't trap it. Yeah, that's one way to say it. And you can only trap the little force bits when you get an electron and a proton together. Now you can trap it in a circle. All right. Or in a back and forth trap. So it's that intermediate step of the electron and the proton that make it a little complicated, because when you say the word matter, do you mean atom or do you mean electron and proton? Obviously, it's a level of difference. Just like there's a level of difference between a living cell and a cellular organism. We call them both alive, but they're really fundamentally different. Cells are very different from complex cellular organism, just like an atom is very different from electron and proton. All right, so the electron and the proton are the real matter bits. So the real universe is really just the little force bits moving the speed of light in different configurations, and the electrons and the protons. And that's all there is in the real universe. That's the only place real interactions happen. That is, real fish happen. And everything else is an illusion. Everything else is more schools of fish. School of fish, school of fish, school of fish, school of fish. But the real mechanism, let's see. Yeah, that's where the school of fish analogy fails, is the fact that you have to recognize that the schools of fish are, there's electron school and proton school, and you can combine those schools into complex arrangements. Yeah, there's the metaphor doesn't work because you can't make magnetism out of schools of fish. And it's really the magnetic force between the electrons and the protons that hold the atoms together. So the atoms are held together by that manifestation of gravity, magnetism, the segregation of the force, because the electrons and the protons are the monopoles. All right, so there's just one. So the analogy fails just because you don't have there's no other place in the world where you have something that duplicates that transition from little force bit and matter bit, and then you have this complex relationship of the inverse reaction, the yin yang thing or whatever, to create another level of complexity. Because our complexity seems kind of obvious in the sense that it's all cells in a fluid. So it's basically a colony of coral or something, and we've trapped it inside the skin, but our little coral cells are still living inside the seawater. We're like in a bubble of seawater. We're really just a bunch of we're a sponge inside of a skin bubble. I don't know, but obviously we have liver sponge, kidney sponge. We have different varieties of sponge doing different jobs. Yeah, so there's no real good metaphor for the fact that, our language, it breaks down a little bit just because we're using the same word. So matter is understood to be electrons and protons, and matter is understood to be atoms. And that's just as bad as calling a cell a living thing and then calling me a living thing, using the same word for things that are fundamentally, elementally different. One's an elemental component, and one is a emergent uh, mechanism. So the atom is the emergent mechanism of the elemental function of the fact that electrons and protons are accelerated when they're hit by force bits. Yeah. Pretty good. All right, so this is all heading for where I want to do this, take each subject and break it down. But that's where it got kind of complicated, because I was thinking about this idea. So you have this word periodic, and you can understand that as being something that's elemental. Like Feynman would argue the periodicness of, say, the pattern in the two-slit experiment, or the periodicness of the pattern in the reflectivity of light on glass, or any place this periodic pattern shows up, this thing that looks like an interference pattern. Feynman would argue that that's a randomness built in to the universe, that probability is a function of Heisenberg, the sense that things don't really have a location, and that they only have one when you force them to be real. So they're unreal until you force them to be real, and that's when this probability is imposed. Where these other people use this concept of interference, where they're going to imply that there is some physical mechanism, a wave function that the photon actually has, that it manifests some sort of physical thing that does this interaction through interaction. Interference is interaction, and that interaction creates an on-off pattern, except they're going to blame that interference on some sort of wave mechanism when it's really just an on-off pattern. You could blame it on something turning. So I could just say, if I had something spinning here and I sent my hand through, now there's periods when my finger's over here, this is going to go straight through. When my finger's over here, it's going to deflect. And when my finger is coming down this way, you could say it's going to, do something catastrophic to my hand. When it's going this way, it's going to deflect it this way, let's say. I'm just saying you can see how this has a periodic function, and it will create probabilistic changes depending on what position this interaction takes place in. So the interaction is the interference, right? The two things interfere with each other when they interact with each other, and they're going to interact with each other in different positions based on the period of this movement. So I'm just saying that, to me, seems much more probabilistic in terms of a correct answer, that the probability is being created by the matter, which contains the periodic elements, the elements that might have a periodic movement to them. They might be oscillating, they might be vibrating, but they're doing it probabilistically, in the sense that they spend a certain amount of time in all locations, and that will be revealed in the outcome eventually. So here you have a concept of interference that really is connected to periodic, and what you're really trying to find is what is more rational to blame for the periodic function. A photon doing this, like not knowing where it is, or more likely electrons on the surface of materials having a periodic vibration. Which one seems more likely? If you're just giving that limited question, I'm just saying it seems kind of obvious that it's easier to blame the matter, because the matter has a lot more complexity than the elemental photon, which always appears to move in a straight line between point A and B. And there's no evidence that it bends ever, or is bent ever. All right. And so then that word gets stuck to frequency, because period and interference, again, will produce something that could appear to have a frequency. And the frequency ends up being intensity, right? Because the faster you shoot the bullets, the more bullets you can shoot in 1 second. So the more energy you can deliver in a system, the smaller the frequency, and the less you can deliver to a system, the bigger the frequency, just as potential. So if I can't shoot the gun any faster than 1 bullet a minute, then I can't possibly deliver more energy than that 1 bullet a minute. Where if I can go 1 bullet a second, then I have the choice of shooting it 1 every minute, but I also have the choice of creating a great deal of energy by shooting once every second. All right. All right, so matter plus fields. So the fields are always just forces. So you could just go matter plus fields. So just get rid of the idea of a field and just say a field only means something when there's a force in it. So let's just think of matter and force. And then you have matter and energy, which just means the force is actually just some bit that's moving. So the movement is in the force bit, the quanta of movement, the quanta of energy. So it's moving the speed of light. That's the energy. And you really don't need to think of it either as a force or a field to understand that it's a bit of energy and that its movement can be trapped. So it can be held inside of something. So all you really have is free energy, which is a photon, for example, or gravity, or magnetism. That's the stuff when you let it loose. And then there's stuff that's held. There's momentum that's held by matter, and that matter's moving is a acknowledgement that it has acquired an imbalance. It collected more stuff going one way than it collected going the other way, and it kept it. It took more ping pong balls going one way than it took going the other way, kept. And because it did that, it caught. It has that motion to reveal that imbalance in what it captured. All right, and then you just get into amounts and density arguments. Now, the question of whether an electron can get heavier or lighter, I don't think they can. They can just have more or less momentum, and their momentum is their weight. So like a photon, they don't weigh anything until you make them move. Photons only weigh something in the direction they land. So they have weight in the direction they're moving. But all other directions, they have no weight. Now, I made these arguments before, but I might as well throw them in here to sum up. All right, so no comments. Okay, not much I can do about that. I can only provide you the opportunity to contribute or say something or anything, but nothing. So I don't think I need to go into this any deeper, so I'll just do some images, I guess. So, I mean, this is just the school of fish, just to get the idea that this is just basically the atoms move as a school of fish, and the atoms move based on what they've collected. And that's just like a planet. If a planet has velocity, it got it from somewhere. It didn't have it innately. It had to collect the velocity fish by fish by fish. It had to get the force pushed into it. If astronauts are sitting in the space shuttle and it's launching, they're getting force thrown into them, and they're going to keep that force until something lets it back out, until you have an equal but opposite action, another force going the opposite direction to release that force, to let those fish free. Until you let them free, you're going to keep that velocity. And you can add other velocities to it, but until you take away something that has some component in the opposite direction, like these have components in opposite directions. So these two vectors would balance out to, something less than this. Well, obviously they balanced out to this, but anyway, let's say that right. But it's a net. It's net in a dimension, and it's the dimensions are where the exchanges are taking place. You take in something this way, you give something away this way, and there's a net effect on your motion in any one dimensional direction. But it's all plus and minus, and it's all conserved in the end. And you have to absorb energy to appear as if you have energy, or you can convert into potential energy in that you have it caught in circles, and you can let it go anywhere at any time. All right, that's enough of that. So we will. So this is the speed of force, just for fun, just to see what would come up. And obviously, there's lots of force equations and some references to speed, but yeah, nothing that really says what I'm saying, which is all of the energy is essentially caught up in this one kind of force, where these little bits are causing all the acceleration. The space shuttle engine is doing the same thing gravity is doing. It's hitting you with a bunch of force in a direction. And although gravity doesn't look like a big hot flame, that's what it is. I mean, it is in effect. And it's just doing it in a way that's completely benign and doesn't burn us to a cinder. But it's exactly the same mechanism. It's just fish in a less hostile form. So all acceleration, by Einstein's rules, you can't tell the difference. It looks like it's all the same, and it looks that way because it is all the same. All acceleration is the absorption of these little quanta of moving bit, moving force, moving stuff. Ping pong balls. All right, this is just energy, which they don't do much with. Obviously, these are kind of generic-y. Lots of blue. I guess blue is more energetic. So it's all turned to blue, 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 blue. But at least there's a battery indicating the idea of storing it. But the storage is always in pressure. Moving things closer together is a way of creating potential energy. I'm just saying, I'm just thinking that one through. I mean, it obviously works out that way, but not on the electron and proton level. It works that way for atoms because they're always going to have magnetic forces and tension. So they will have a lot of traps. Nothing there I can do much with. And that's force. Yeah, there wasn't much there either, just cartoons. You don't get the idea of little bits or quanta, the idea that fields are nothing without the force being in them, that you have force because you absorb the force. Again, the airplane has to burn fuel to gain the force. The runner has to consume friction on the ground and do pushing and consume energy to gain force, to gain momentum, to gain speed. It's all, it's all requires you to consume fish in one direction to make your fish move in a direction. All right. I don't think that's it. Yes, I think that's it. All right. I think there might have been a comment or two. I might as well just do them quickly. Get the hell out of here. They're junk as usual. Yeah, no comments worth noticing. All right. Notice of eviction. So again, this is like the Cowboys. Take note that you are hereby given notice that to vacate the premises within 9 days. I mean, this is like getting into this, personal shit that's just really obscenely obnoxious. Yeah, just, it's disgusting. I don't know why. Just don't know why people like this. How do you I mean, what kind of creatures raise this creature? What kind of disgusting people? So Michael Falwell is kind of off the subject here again, I think. All right, little off topic, yes. But I've been thinking about these slit experiments. Yeah, I know, but we don't think about them the same way, so sometimes I don't think this is very productive. But anyway, if we think of the slit as two surfaces, yes, in close proximity to each other, yes, with surface electrons on each surface, yes. While the electrons are not strictly tied to the atoms in the material, well, they probably are kind of strictly tied. But anyway, it doesn't matter. The close proximity of the surface to each other and all being of like charge, could this cause the electrons to arrange in a rigid order due to repulsive forces between them? I think the more, um, I think the better explanation is that, like with this, the impediment argument of the two slits, there's a bunch of energy that hits the center impediment, and that clearly vibrates everything inside of this impediment. That vibrates these two surfaces. That makes sense to me. And so that's why the double slit pattern is different. These two surfaces create a different pattern than they would create if they were just an open slit. All right, what else is different? And you could argue the same is true for the single slit. When you make this slit smaller and smaller, that means more and more light's hitting the surfaces. That is, it's hitting the stuff that the surface is made out of. And so as the slits get closer, you're hitting this with more and more photons, which means the surface would get vibrated more. You could think theoretically the electrons have more wobble to them. So that could be that that's just the reason why the pattern changes, is because the period of the vibration of the surface electrons, that vibration changes its period. And that's why the pattern has a different period as you bring the slits closer together. Okay, let's go further. All right, surface each other all being like, okay, could this be the cause of electrons to arrange into a rigid order due to repulsive forces between them? Like I said, it goes back to even the Newton's glass experiment. Okay, the idea that you make the glass thinner and thinner, you rub off some of this top surface. But theoretically, when you're doing that, you're also changing the bottom surface, because you're basically changing how the electrons are how the atoms are lined up with each other. So when you're polishing the surface, you're changing this arrangement. The atoms have to line up either like this, like ideally they want to be this, or they want to be this. And as you're polishing, you're forcing them to be in a condition they don't like to be in. So they're going to do this change thing. And when they do the change thing, you see they're going to change the top and the bottom at the same time. So as you polish, you're really going to be forcing these configurations to change. Which one flips? And so you're changing the bottom height at the same time. So that's what it's probably more like. All right. Then I also remembered that you mentioned that when two surfaces come together, one tends to go positive and one go negative. That will inevitably happen, but it happens by a process where innately it has an innate efficiency built into it, because again, this is all frictionless. And so essentially, yes, it's a lot of dominoes that are going to flip. But, and somehow, just by probability, they're going to flip in such a way that it's like the same thing happens with orbits. So if I throw a bunch of marbles onto one of these bent fabric things, right? I throw a bunch of marbles I throw some going one way and I throw some going the other way. The fact is, all the marbles will hit each other, and in the end, they'll only all be going one way. So any marble, the circumstance will dictate that the outcome will always be that the marbles will either be going all this way, or the marbles will all be going this way. But there won't be any more marbles going both ways. And that's sort of what's happening, is there's a certain, one side just has a bias a little bit. So essentially when you threw the marbles in, you already decided, because you threw the marbles in with more energy going one way than the other way. And in the end, it's going to figure that out. They're all going to hit each other, bounce back and forth. And in the end, they're going to figure out which way has more energy. And the last marble is going to be going that way. And the same thing happens when you're flipping these things. These little magnets inside are all flipping to match each other. And it just happens that when you brought the two plates together, one side had more heads than tails, and one side had more tails than heads. And it just happens that they'll figure out which one was which. And one will go positive and one will go negative. All right. It's, it's the best analogy I can give on the top of my head, but it's probably a better one, but I'll think about it. All right, tends to go positive and negative, which would suggest that one surface has an electron bias. Yes, there's always a bias. We can't calculate, we can't see it ahead of time, but the bias is there. One of them has more heads than tails. And it's just true. And so that's going to decide. And one, a proton bias. So that said, if the protons were interacting with electrons to cause the visible light effect, but the interaction with the proton caused an, let's say proton, visible light, so no visible light. Now, there's nothing absorbed. All the light's not absorbed, so you're not consuming any of the photons to create the dark bands. The dark bands are where light doesn't go, and twice as much light goes to the light bands. So in that sense, there's no such thing as photon plus photon equals no photon. Photon plus photon equals photon jumped over here. All right, visible light, or just release the photon back a lower energy state. Well, again, there's no lower energy states, so it's still not visible light being emitted, giving that light no light pattern. So no, it's just the light no light pattern clearly look, even in the math, it's just an angle change, a sine theta angle. And all you're doing to make the dark spaces is you're taking light that would have gone to the dark space and you're moving it here or here. That's it. The light's still going somewhere. The photons all go somewhere. They just don't go here. They go here or here or here or here or here or here, but they don't go to those dark places. All right. Also, just get back on topic, trying even with small magnets, putting them apart requires a lot of force, but why on their perpetual path, perpendicular path, is it so easy to slide them apart? Well, sliding, it just has to do with force. I mean, it'd be easier to slide us off the earth also. So the sliding part just means that it's like leverage. You're taking a thing you're trying to do all at once, which is lift, and you're changing the lifting process and making it much longer. So it's like you only have to lift it a little tiny bit at a time if you slide it. So technically you're just making it longer to do the lifting. And the hardest lift is when they're glued together, right? Surface to surface. So any tilt you can do slow makes it easier to do. If you try to do it this way, it's hard to do. If you take your time and tilt it a little bit, that's much easier to do, right? So it's just a pulley kind of argument. It's just leverage. Sliding creates the opportunity for leverage. And obviously, when you slide two magnets that are face to face like this, well, sliding them not only is no leverage, you're killing the force, because now the magnets aren't in line, so they're not even attracting each other anymore. So sliding just means you're avoiding the force altogether. But let's say the magnets were longer, and you had to pull it off a surface, it'd still be easier to slide it and tilt it than it would be to pull it. So tilting would always make it easier. So the more leverage you have, the more you can reduce the gravitational effect, so to speak, the attractive, the whatever. But clearly sliding just means, oh yeah, there's no force anymore if I slide it right off. All right, so this Brian guy is a little bit annoying. I mean, the first comment was retarded. I think he's a flat earther. So more than this nonsense. Why are you so obsessed with this guy? So I've made videos responses to a few people who make physics videos. Clearly, I've made response videos to documentaries. I made response videos to professors in lectures. I've made response videos to people who have theories. And Ken Wheeler happens to be one of those people, and he happens to have a rather large audience. So yes, I've made a few videos. There's no obsession, idiot. It's a tiny percentage of my videos. Less than 1% of my videos mention Ken Wheeler. Yet you call it an obsession. You fucking cunt. There's no obsession. Seems like a part of you deep down knows he's onto something. So again, just retarded. So every time somebody complains about somebody, it means they love somebody. I mean, you people are just fucking insane. You know, in your perverse, convoluted way of thinking. Especially when I haven't made it so clear in the videos that I'm arguing with what he's saying, you stupid cunt. God damn. I mean, you're just too stupid. To me, what he says is a lot better than quantum theory. Why is it better? Hyperberloid mishmush. Coaxial cable. It's like a coaxial cable. How the fuck is a photon like a coaxial cable, you retard? But I wouldn't obsess over it. Like it's my. I wouldn't obsess over it like it's my religion. No, it's only physics, for fuck's sake. And you don't think it's important enough to have right answers. And even religion, you don't think philosophy matters. It's okay to believe Muhammad is God. That's okay with you if people believe that shit. You're a fucking idiot. Keep an open mind, dude. Fuck yourself till dead, shit for brain. I'm just deleting all your comments. I'm not even going to read the rest of them. This dude fucking bullshit. Fuck you. I mean, I want to call you the N-word. I want to call you something really disgusting. Look, this dude shit has got to stop. I'm not your dude, bro, bud, cunt. All right? I'm not a piece of your property, you fuckhead. God, it's just so irritating. I mean, when I hear dude, I just hear somebody just called me a nigger. That's what I hear. Like somehow this asshole thinks he owns me. Thinks he can call me his dude. I'm not your dude, fuckhead. Not even close. So yeah, fuck off. Oh, the rest of this shit didn't disappear. Well, I'll read a couple of sentences of each one and then I'll just delete it. The problem we need to be working on. Now, the problem we need to be working on is exactly what I'm working on, is pointing out how conventional physics is full of shit and how most of these dissidents are also full of shit. Ken Wheeler isn't any better than the Einstein he mocks. No better whatsoever. He's less. He has less integrity. He has less experiments to defend what he says. He says things for which there's obvious evidence that it's absolute bullshit. This whole crap that he thinks birds see magnetic redshift. He has zero evidence for that kind of horse shit. And you say that UFO nonsense is good. Fuck you. Let's see. I have a few more experiments we could conduct. No, I don't think so. To bash both models, whatever bash means. I think, but maybe not. Yeah, I think maybe not. If you'd like to keep an open mind. No, where do you get the idea that I have an open mind somewhere here? I mean, I'm saying aggressively, Eureka, I've got it. And I'm explaining how I've got it. I mean, I've got an answer that just fits everything. Everything works just fine. I don't need your hyperberloids. I don't need your coaxial cable crap. I don't need your rope theory. I don't need your rubber band theory. I don't need your string theory. I don't need any of your crappy ether. I don't need your electric universe crap. I don't need your mystical crap. I don't need your spiritual crap. I don't need any of your unicorn shit. I don't need your unicorn piss. I don't need any of it because my glue works fine. I don't need any magic crap. Oh, yeah, fuck off. truther, loopter, duper, fucking flat earth nutter. Anyway. All right, so I think now we're done. There's any comments? Still none. Okay. All right, well, I'll give you 1 minute or so. 1 minute and 30 seconds or something. Very disappointing, though. People are very disappointing. I had to spend a half an hour the other day, with the analogy, I use the analogy for time dilation of dancing as fast as you can in one spot. And then I ask you to move to your left, and then you can understand how you can't dance as fast because you have to take some time out to move. And they weren't getting it. And it was, it's just so frustrating. So I'm going through it. And so then I thought of horses. I said, okay, think of a horse track, right? A race track for a horse. Okay. And let's say, how the horse can run a certain speed around the track. And then kind of obviously, if I put a bunch of bales of hay on the track and the horse has to jump over the bales of hay, and now the horse can't run as fast because he has to do this go up in the air thing and come back down. And then they started thinking, well, when the horse is in the air, he's moving faster because he's flying. Like, no, it takes longer because it's a longer path. And it's just like, it was like, oh man, no matter what I say, there's just, people are just going to be belligerently obnoxious to hearing this. And it's, And so another horse analogy would be the horse track itself gets longer in one direction, because the horse track is going to move. So as the horse track moves in one direction, well, that means the horse has to run further here, to go around. And so there's more distance in the track as the track processes in a direction. But, yeah, but then you'd have to point out how the whole track can't move. The other side of the track has to stay where it was, so you're only moving the one length of the track. So that doesn't work either. But it's just a simple multitasking argument. If if you have to do one task, then you can do it at a certain speed. But if somebody asks you to do something else in the middle of what you're doing, I have to answer the phone while I'm doing this video. Obviously, the amount of words I'll be speaking in the video has to change in the amount of time because I have to waste time doing the phone thing. I mean, it's just such an obvious argument. Multitasking consumes time, and when you have velocity, your atoms are multitasking. They're not only doing the atom thing, they're doing we have to move. So they're doing atom stuff, move this way, atom stuff, move this way, atom stuff. And so the faster they're moving, the more time they have to take going this way, and the less time they can take going, I'm an atom doing atom things. But no, people don't get it. So people, there really aren't that much smarter than chimpanzees. And such. Let's see. Am I still alive? See how many people are in here. 17. There should be some more chatters than this. 17. I mean, that's 17. That's not a bad number. I mean, it's bad, but I mean, it's not as bad as it's been. I've had worse numbers and better comments. But anyway, I guess nobody's got anything. No one can do physics. I gotta get a better audience. I got people watching, 17 people. Apparently can't say anything relevant to physics. You know, and they're watching. So I gotta find people that know something about physics. Somebody can make a counter argument. Do something useful. All right. Well, anyway, till next time, where I will probably start making more specific videos. But I mean, it's just such an important point. That, as soon as you start getting specific, as soon as I say the word interference, you just open the door to all these other subjects. Because that really is just saying, what's interfering? Come on, get real. Wave functions, come on. It's not a good enough answer.